We have what we make indirect drinking water. The first stage is secondary effluent comes over into our plant. The first stage we have is ozonating that water. Generally, the reason for ozonation is to break up small organic compounds so it won't clog, if you will, our microfiltration system, which is the second stage.
Ozone is a highly reactive gas. When injected into water, oxygen radicals are formed. These free oxygen atoms work like missiles that attack and destroy some of the bacterial and viral content and helps to break up complex compounds such as fatty acids. This makes them more easily consumed in the subsequent treatment steps.
Microfiltration are tiny pores that really filter out if there's any small solids in the water itself.
During microfiltration, water is forced through racks of vessels, with each vessel containing thousands of hollow fibers. The outer wall of each fiber is made up of tiny pores only 0.4 microns in size, or about 300 times smaller than the width of a human hair. The fibers filter out microscopic particles such as silt, protozoan cysts, bacteria, and even viruses. Microfiltration vessels are backwashed every 30 minutes to remove any buildup of particles on the membrane walls. The backwash water is returned to the pre-treatment tank for reprocessing. This helps the plant recover a higher amount of pure water.
I relate it to, it's sort of the artery to the heart. The microfilters are the artery, and then the real heart of the system is reverse osmosis, which takes out dissolved minerals and dissolved organic compounds in the water itself.
Reverse osmosis works by forcing water through a special plastic membrane sheet to remove compounds such as salts, organic compounds, microorganisms, viruses, and pharmaceuticals. Rolls of membrane sheets are wound into cylinder-shaped elements. There are several elements inside each long-pressure vessel. As water enters the vessel, it flows over the membrane surface as it moves from one end of the vessel to the other. The membrane layer is extremely thin. It allows water to pass through or permeate, while preventing other compounds from passing through. Membranes remove molecules based on their size, shape, and charge. Generally, contaminants larger than water molecules will not pass through, including most chemical contaminants and all microorganisms such as viruses and bacteria. Two streams of water are produced. Pure, clean water or permeate flows across the membrane sheets and passes through the membrane layers to the inside core tube. Water that does not permeate becomes more highly concentrated with salts and other substances. This water is called concentrate. The pure permeate water flows out the core tube and one end of the pressure vessel, and the concentrate water flows out another outlet. The concentrate water can then flow into other pressure vessels for the same process to happen again, so even more pure permeate water can be recovered.
Then we disinfect it with UV radiation light, sort of like a tanning salon times 10 is the type of light that we actually exude to the source water itself. And then we have the final polishing stage, which we add hydrogen peroxide for advanced oxidation of that water.
The next stage is ultraviolet light and advanced oxidation. The water is dosed with hydrogen peroxide and is exposed to strong UV light. This process removes any trace organic molecules. The UV energy instantly destroys the genetic material or DNA of any virus that may somehow have passed through previous barriers. Intense UV light and oxidation breaks down contaminant molecules. The process is similar to ones used in medicine and dentistry to sterilize equipment.
What we do, we're the supplier of the water. There's another jurisdiction that operates what we call the injection barrier system, and there's 153 injection wells from essentially Los Angeles International Airport, LAX, all the way down to the Palos Verdes Peninsula. And these 153 straws that go underground as deep as 1,000 feet, this water then is forced under pressure underground to refill the aquifer, to replenish the wells, but also to hold out the seawater.